In the last video, we checked at a live example of Starbucks request smuggling and also how to test and confirm CLTE and TECL vulnerabilities. In this video, we look at exploiting request smuggling, how we can bypass access control with request smuggling, and combining cross-site scripting with request smuggling to show impact. This is the 19th video on our bug bounty playlist, so check out other videos too. Follow me on Instagram and also check out the GitHub page. It contains blogs and guides on CTFs, reverse engineering, bug bounty, API, and APK hacking. I will link it down in the description. So let's start the video. First, we will look at how we can bypass access control with request smuggling. For that, I will select a get request to slash route. So first things first, we need to test what is the architecture of our target. Is it CLTE based or TCL based? My last video, I explained how to test and how to confirm in a detailed way. So we are not wasting any more time. So let's set our payload and send. We add a byte more than what we give in the content length and send the request. If you get a timeout, it is CLTE based. Make sure to turn off automatically update content length. After sending the request, we got a timeout. So this is CLTE based. Now to bypass access control, let's try to access the admin page of this site. A normal user account do not have the authorization to access the admin page. So here we will use request smuggling to smuggle an extra request and try to access the page. Since the backend uses transfer encoding, we will use terminating 0 and add our request. Now create a get request to slash admin. I'll add a dummy header and send it. We got an error. Why? Because look at the content length. It's best to turn on update content length automatically while smuggling the request. So we don't need to update it ourselves. Now let's send the request again. We get a 200 OK. Now let's create a normal user's request. And this is how it will look when a normal user sends the request. After sending, we got a 401 unauthorized. Admin page is only accessible by local users. From this error, we can find that there is a admin page at slash admin. So what happened here? When I sent this post request, the backend server added the get slash admin request to the top of the post request because 0 is considered the end of the first request and our smuggled request got added to the top of the next request. Now let's look at the error. Admin page only accessible by local users. So let's change our host to localhost because it is a local user. Our second request should reveal the admin page. We got an error. Duplicate header names. So what happened here? Did you notice one thing? Our smuggled get request is not a complete request. So what happened here is when we send the second request, it got added in this way. So when the server checks, it sees two host headers. That's the reason we got the error. So let's create a complete request. We'll add other headers, content type, content length, and let's add our channel name as content. Now this will work fine as the next post request will come after the content. So it will look like a complete request. Now I will show you how the server will see this. I'll copy the post request. Then the server will add the post request after our smuggled get request. And hopefully we might get access to the admin page. So let's send our attack request first, then the normal request. And we got access to the slash admin page. Now we can see all the users and there is also an option to delete. So let's try to delete a user. The route is slash admin slash delete username. Just send a request and we are able to delete the user. So now our bug has an impact. It's not just a request smuggling bug. Now we used it to find an access control issue. This is now a proper impactful bug. The second exploit is increase the impact of a reflected XSS using request smuggling. This is a blog site and this is a request made to one of the blog. There is a small issue with this code. The contents of the user agent header gets inputted to this site. So can we put our own text? Let's check. I will type in Zodiac and send the request. Let's search if our text is reflected there. So whatever text we give is added. What if we input a code? If it poorly sanitizes the input data the user is giving, then there is a chance for reflected excesses. Now let's close our input tag and put a script tag. Let's see if the server will see this as a text or a code. After inputting our payload, let's send the request. Search for the text Zodiac and we can see our script tag got added to the code. Now let's run it in a browser. Right click, request in browser in original session, copy and open the browser and run it. If it's working, we will get an alert. Okay, subscribe. So the reflected XSS is working. But this is a low impact bug. Now to increase the impact, we can use request smuggling to make this reflected XSS run on a normal user's account. If it works, we can use this to steal the user session and make the user do anything we want. For that, let's choose a get request and make the necessary changes to test what kind of architecture is running in the background. And we get a timeout. So it is CLTE based. Do you want to know how to test TCL based? Check the video just before this. Now let's smuggle our request. Create a get request to the route we found the vulnerability in and add the necessary headers. In the content length, add a byte more than the content you give. Now add the user agent header and also our payload. Make sure you add the route to the vulnerable page. And also make sure you turn on update content length from the settings above. Make sure you added everything correctly and then send the attack request. As an attacker, we will get the 200 OK from the above post request. Now, when a normal user tries to access the page, the reflected XSS runs on their end. This is enough to show the impact of this bug. So, what happened here? Our GET request to the vulnerable route got added on to the top of the user's normal request. So, we changed a low impact reflected XSS to the high impact bug. If you like my content, like and subscribe.